Hello, this is Lubna, and I am here to show you a demo about my contribution in data analytics and machine learning domain on this topic, prediction of student performance by modeling small data set size. Pointing that I am exploring master student datasets who are specialized in informatics. And the main goals of this research is to, first of all, know if the prediction of student performance in dissertation project and all courses uh, can be achieved using small data using by the training of small data set size and with uh, credible or acceptable accuracy rate. And the second thing that I would like to explore here is the how visualization and clustering technique could be helpful in extracting important indicators that will help us in creating our prediction model. Uh, so why I am doing this and what is the benefit of this research? First of all, we know that any university seeks to predict student performance for many reasons, like detect at-risk student beforehand so they can help them to boost their performance and achieve good mark at the end of the courses, for example, or to know if the learning process is going well or it needs any improvement. And another important thing is that some of the outstanding institutes are seeking for engaging. They used to engage distinct students in uh, useful projects that will return benefits uh, to them and the student themselves by improving by engaging them in solving real world issue and from the university stand i- they will participate in improving their reputation and improve their ranking among other universities. So that's the main aim of this project, and to achieve these aims, I will uh, answer the following research questions. Uh, the first one is to identify the key indicators that could help in creating credible, uh, accurate classification model for predicting student dissertation project grade. And the second question is to know if the student performance in any course, excluding the dissertation, be predicted with reasonable accuracy rate using only student pre-admission records or course name and instructor name. So the first thing that I started with is to uh, no during this research I crossed through different phases, and these phases are first of all I prepared the data set to be ready to be analyzed. And then I extract the indicator from this dataset. Then I inject the indicator in classification model, and I started to evaluate these different classification model. So um, first of all, I would like to show you um, the the dataset that I received, so you can see how it is look like. Now, this is the lesson that I received it from the admission people, uh, and as you can see, for me and for my research, I find that there are the extra attributes that I don't need them. So in the preparation stage, I try to I remove these. Uh, these unwanted attributes like the bachelor institution, like the course description, status, since all of it is the same values, and what else, the Moodle code as well. And also I find out that the students who did their master program before 2010, they used to take 7 courses, as what you can see here. 1, 2, 3, 4, 5, 6. No, they used to take 9 courses. But however, those who are registered after that, uh, they took only 7 courses. Like, for example, this student, as you can see, 1, 2, 3, 4, 5, 6, 7. So what I did now, since it's until today, it's 7 courses, I removed 2 courses from all the students that it's not anymore taken uh, in the current master program curriculum. This is the second thing that I did. The third thing, now you can see that here uh, there's students. I will show you. There's students who have very one record, for example, and like student number 51, 52. There are another student here, I think. Um, anyway, I tried to also remove them um, since I'm keeping only those students who have the same number of records to do the analysis. I mean, fair for all the students. One last thing I did, and I converted the attributes, as what you will see here. This is the file that I changed it, the changed file, the updated file. Now, for example, the grade I converted to numeric numbers. The instructor here, I will show you here as well. And the instructor, the provisioned one was in this way, and I converted to this way. And I did that only by uh, putting an if else statement, and after that, when it's applied, I just shift control down arrow, copy it and paste it as a value in another sheet that contains only the attributes of my interest. Why I changed the uh, why I changed these values to numeric values. Now I did that for many reasons, and I was trying to follow best practices on that. First of all, um, as you can see here now, for the model description, you can see that it contains multiple strings, and these strings, if it will be stored in memory to be executed later, it will take lots of memory, and it might spend long time. We might not feel that with our small data set while in execution, but if it's big data set, yeah, we will suffer from this issue. So I am trying to just convert this to numeric, just uh, uh, to follow the best practice, and at the same time I would like to uh, for certain classification algorithm I will use normalization. Normalization require that attributes to be fed uh, in numeric type. So I converted all of that. So once I finished from the encoding, I removed those uh, the the uh, the nominal attributes version of them. So um, I ended up with this dataset that contains student ID, uh, their bachelor degree, and their GPA, and their age, and the courses taken by each student, and the instructor name for these courses, and the grades on these courses. Now, this to answer or to this could be helpful in its way, and I mean, how it. Um, I mean, this will be ready to answer uh, this research question that relates to prediction of student in all courses grade, and check if instructor or course or their pre-admission record could affect the prediction of their grades in their courses. So for research question 2, this dataset is ready. However, for answering the research question 1, which is the prediction of student performance in his dissertation, um, since I would like to also see how the grades of each course will affect the prediction of this um, of student performance in dissertation, I created a Python code that will take that will create new columns. Um, these columns are the number of the courses taken by student and the instructor of each course and the grade of each course. So, uh, so the output of this Python algorithm or program, Python program, sorry, is this file. So as you can see, all the student or all the records related to each student is scattered in one row. Like here, these are the new columns: grade one, course one, instructor one, and grade two, instructor two, until we will reach to the dissertation course number and instructor, which is not provisioned, and the grade. So now this dataset is the one that will be used for um, uh, answering the research question 1. Now, once this dataset is ready, I moved to the next step, which is to extract the indicators that will help us in creating the prediction model visually using R. So I will start by let's say uh, before anything. Now uh, I would like to say that I applied I um, uh, first of all I will start with this dataset 2 and the research question 1 and the prediction of student performance and the dissertation grade. So the first thing that I did is that I read that file that we will analyze, which is the one that we just saw, and after that I tried to find the missing values in these files. As you can see, we in grade 1 there is one missing, two to one missing values, and there's some missing values in the dissertation grade, and also as we saw that instructor uh, de- details for dissertation grade is not provisioned. So uh, since instructor details is not there, I decided to remove it, and the rest of the missing, I replaced them with the mood of each attribute. Now to see now the mood to see the mood of each attributes, I ran this algorithm summary of the input, and let's say no, sorry, summary No summary, sorry. So summary. Let's try this. Yeah. So this show uh, shows us the attributes and details related to these attributes. Now, since the missings was in grade 1 and grade 2, let's see grade 1, no, grade and, oh yeah, grade and grade 1, which means the dissertation grade and grade 1. Here's the mode. Here you can see that there's one missing, and in the grade here you can see that there is three missing attributes. So so summary will show us also the missing values in each attribute, but see how it's easily to identify it visually and so fast. Now to find the mood in this value, because I'm going to replace the missings with the mood for a different reason. I will state it later. I went to the Excel sheet and I select the column, and I ran a data analysis package, and I chose descriptive statistics. Okay, I have to reselect it again. Shift Control down arrow. Okay, and I clicked OK. Okay, summary statistics and OK. Now, as you can see, the mode is 4 for grade 1 attributes, and similarly I did the same for dissertation grade, and also the mode was 4. Then I replaced the missings by running these two lines of code, like whenever there is a non values, replace them with 4. After that, uh, remember that we regarding the missing attributes, why I replaced by mode. First of all, because there's another way of replacing missing values, like replacing by mean, or replacing by uh, uh, doing regression imputation, but and others. But I find this is more easy. First of all, second, I would like, for example, in my attributes to preserve their classes. I don't want to have a continuous number. I would like to have the grades uh, classes as it is, and I don't want to create new classes. So because of these two reasons mainly, I replaced by the median. Now, after reading the dataset to replacing missing values, uh, what I did after that, yeah. So I said that we will try to identify the uh, key indicators, but um, now before running the visualization analysis, um, those that had standard deviation of 0 or variance of 0, or in another word, that those attributes that have similar values, I try to nullify them to avoid the errors in the visualization process, and actually it will not have any effect in uh, those grades and predicting the grade of the student in the dissertation course. So I nullified them. Also the student ID. Then uh, for the student age, since it will be ranged from 30 to 50, I try to normalize it to a range of the values that is frequently used in different attributes, which is from 1 to 4. So I ran this algorithm, this line of code, and after that I created a matrix that will be fed to the heat map that we that okay yeah, it's already installed. So I will run the heat map visualization graph, and as you can see here, there are attributes that have no effect on the grade of the students, like instructor 1, instructor 6, course 1, course 5, and these attributes. However, we can see here that there is a certain rhythm, like those students who achieved in grade 2 and grade 5 and grade 3 uh, high mark, they are expected to receive, or they received high marks in dissertation grade. However, those who received low marks, they received also as well low marks in dissertation grade. But whenever we will go in the right side, uh, this correlation is decreased, like in uh, BSc GPA grade, still grade 4 is having the same rhythm, and whenever they have here high grade, most of them having high grade in the dissertation grade. So to identify the attributes more clearly, I used a hierarchical clustering algorithm, but just for the columns, because I am interested to see the relation between or the correlation between the columns only, regardless of the rows. So I plot the dendrogram for this hierarchical after hierarchical clustering is applied, and this is the result. So as you can see that the grade, the student grade is mainly correlated with grade 2, and then grade 1, and then grade 5 and grade 6. But as what it's shown here, that all the grades here is forming one cluster. That's mean they are near to each other. That's mean there is a sort of relationship between all of them. So if we will cut this dendrogram from this height, we will end up with this cluster. So I ended up deciding to take this cluster, and the attributes in this cluster, I consider them as my key indicators for prediction of student performance in dissertation grade. So once the same process is applied for identifying the key indicators uh, for prediction of student performance in all courses. Uh, but I will continue now with the first question. Now, after I identify the indicators, I went to I have to feed them to the classification algorithm. Now, to feed them in the classification algorithm and evaluate them, we need some sorts of baseline for that accuracy evaluation process. Like we will refer to a line to say that it's good, it's good accuracy rate or acceptable accuracy rate or not. So um, I from this frequency table, now I run this algorithm to yeah, this algorithm run. So this will give us, it's a sort of frequency table. It will give us the number of the occurrence of each label in the class grade. And I created a baseline by taking uh, the number that have the highest occurrence in the grade class, um, and I divided that by the total number of attributes in that total number of instances in that classes to create the baseline. So this is my baseline. It is this number. Uh, no, I think I am mistaken here. So this is for dataset 2, and this should be my baseline. And this is the baseline. Oh no. So no, I was mistaken here. So yes, I was right at the beginning. I should run this because I was trying to trace back what was the issue. So here, yes, it is the uh, number of occurrence grade 4 is appeared, and this is the length. So the baseline will be around 60, uh, around 60%. So now from this stage or from this baseline, I will judge if the classifier are doing good or not. So for the classifier, I used a different classification algorithm, and they are uh, naive Bayes, k-nearest neighbor algorithm, and linear discrimination analysis, and SVM, support vector machine radial, and multiple perceptron machine learning algorithm. But I would like to note one thing that from the literature that I read, I understand that all of them can accept nominal and numerical attributes. So I I converted all the attributes as factors, and I ran the algorithms. Sorry, let's see. I ran all the algorithms. I think Caret is not installed. Let's see. Okay, I should run this one first. Requires let's. So I will install the needed package, and I will come back. So the Caret package was not installed properly, so I reinstalled that. Now I am coming back to the classifiers. So I run all the classifier using the factor attributes. And this is, I would like to note one thing here. Um, this uh, this line of code will train the whole data set, and I did not create training set or testing set. However, I used a method called for validation, leave one out cross validation method. This will allow me to utilize fully from the dataset to create to be trained and to create the prediction model, and at the same time it will leave only one instance out, and it will test the new model with this instance until at the end it will gather the average of the accuracy of all the iteration, because it will iterate on each point in that dataset. So it will point by point, it will take one out and train the model, then it will take the next point out and it will train the model. So until at the end it will give us the average accuracy rate. So now the models are created, and as you can see here, for each model, now this is the naive Bayes output we can see that the accuracy model is 65 and the kappa is 17 percent. Now I told you that I will compare between numerical and factor attributes. So converted I converted all the attributes to a factor, and I ran the models, and I extract this accuracy result, and I did the same, and for the numeric I converted them to the numeric one, and I got the result. And here I will show you the last table that shows the comparison between numerical and, yeah, here. So this is for the dataset 2, and as you can see, using numerical attributes, this was the accuracy and the kappa result for all the models. However, using the nominal one, these are the results. But at the end, uh, uh, I only chose the for dataset 2 the data type that gave the model highest accuracy. So I ended up with taking MLPN and as a numeric and LDA as a numeric data type. I mean, the attributes to this function as a numeric data type, but however for the rest as nominal one. And as you can see, the highest here is the support vector machine that had the highest accuracy. Uh, so, and if we will compare this 76 with the 60% that we got as a baseline, we will find that we got an acceptable and credible model. So I repeated the same, and I did the same for the dataset one in creating all courses. In extracting all courses. First of all, I identified, I replaced the missing value with the means as what I saw you, and then I created the heat map, and from the heat map I created as well no I created as well the clustering, hierarchical clustering I ran the hierarchical clustering algorithm, and I created the dendrogram. Ended up with only 3 attributes. uh, that's it. So I did one more thing at the end. I To say that it's the output accuracy is credible or not, I ran these lines of code. Now, what this line of code will do? Now, first of all, this line, it will take. Now, here I will try to calculate the p-value, and my hypothesis was if the p-value is less than 0.05, that means the null hypothesis will be rejected, and the null hypothesis was there is no difference between the previous accuracy and the new accuracy one. So I extracted, so from here I will show you what I did. Now if we will view this one, this will show you the prediction of the variable, the observation. um, yeah I created a confusion matrix, and I extracted the observed prediction and the observed attributes versus the the actual grade attributes and the observed one, and I created the confusion matrix, and then this is the result. So this is the confusion matrix, and it showed me also the accuracy as well one more time. And you can see here the p-value is 0.31. So by doing by running this, I extracted this value, which is 0.031. What is this? Oh no, using this one, it will take for me the p-value. So as you can see, this is the p-value in the confusion matrix. So I gathered the p-value for all the confusion matrices of these models, and I compared among them, and I found as well this similar output. That's the support vector machine have lowest uh, the lowest p-value. As you can see from this graph, support vector machine have the lowest p-value, which will reject the null hypothesis, and that's mean there's a big difference here, and of course it's the difference to the best. uh, One more thing I tried here is the um, uh, I tried something called balanced accuracy. Now, balanced accuracy will is something like kappa. Now, kappa result, the one that we saw here, this result here, there's no kappa results. That's mean because we are training. No, there is kappa result here. That's mean it's 70% more than the random prediction of that number than the baseline that we created. So it's 40% better. So using this prediction model, it is 70% better than if we will use random prediction. So there's another more reliable accuracy measure or validation evaluation um, metric, which is called balanced accuracy. Now this balanced accuracy is a by class measure that will tell you it is the average of the sensitivity and the specificity divide yeah sensitivity and specificity. So I extracted this. So I chose to get the balanced accuracy of the most occurrent class, class 4, and compare it with the baseline that we calculated earlier to also see how it's if it's more or less than what than the random prediction. And um, why I use this, because I would like to um, remove the bias that the model might have in training a data set that it's not balanced. For example, now in the data set 2 that we have, we saw that class 4 have the the most frequent repeated class among the rest. So um, uh, I use this measure to see if the class was biased by that or not. So I calculated that, and I find out that this is the result now for our dataset 2. For support vector machine, the result was 73% for prediction of uh, class 4 grade, for the class 4 grade, 73. However, LDA was more accurate than SVM. So that might tell that SVM have quite a bit bias in such this kind of imbalance issue in our dataset. However, LDA was more accurate. Um, uh, so uh, this is needed to be explored in further in the future, and I was aiming to use another matrices like ROC curve and F measures to really see and confirm which is more better, LDA or SVM. But until now, both of them are near to each other, and both of them are good in training small data set size. But I hope that I have more time to explore that more using another accuracy metrics. So the same thing is repeated for dataset 1 to extract to know student performance in all courses, and I find out that there is I will will show you in rapid. So here and here I replaced the missing attributes, and here I removed, by this code I removed the dissertation course and its relative details, since I measured the dissertation in the exploring dataset 2. I predicting it already. This and this will allow me to create the baseline as well. And for dataset 2 I nullified student ID and sequence number. Also here I will show you now the heat map. Also for student age I normalize it. Zoom. As you can see here, GPA is the most it's quite not clear using the heat map, but it's more near than the rest to uh, to the grades. There's sort very quiet uh, small correlation between them, but it's the nearest one. But to see more, what are the correlated attributes to student grades in all courses, and I found that student age and degree and GPA are the most correlated one, but not the instructing course. So they did not form cluster with grades. Then I repeated what I did by comparing different type of attributes, um, uh, using the data type or the attribute type that give me the highest accuracy in each grading model, and then I figure out the p-value to say if my accuracy is good or not, and at the end I also measure the balanced accuracy as well. So that's it, and I hope that I was clear in describing what I did, and thank you for your listening.